Hello, everyone. My name is Jose. Joining me are my teammates Caela, John, Samir, and Zachary. Our faculty advisor for this project is Dr. Lei. We are Team 1, and our project is the Smart Cane, which is an upgraded version of the white cane meant to improve the quality of life of its users. Have you ever considered how many people globally suffer from some form of visual disease? Today, over 2.2 billion people globally suffer from a visual impairment. Thankfully, the white cane was invented in 1921 to aid those affected to navigate themselves.
The use of the white cane will always be needed as the population of the visually impaired in the US is expected to exceed 25 million by 2050. However, even with the white cane, 98% of visually impaired encounter at least one head-level collision throughout their lifetime. What we need to solve this issue is to first investigate the techniques used by visually impaired to use the white cane and to look at which objects and structures most cause the injuries.
So the goal of this project was to develop a smart cane that detects objects above the waist level to improve the safety of a traditional white cane by notifying the users of objects ahead of time.
And in order to develop the smart cane, each team member was placed into specific tasks based on their cultivated skills and past professional experiences to really maximize the effort put into the cane.
Our cane has a capability of detecting objects within 3 meters. The user is notified with vibrational motors and speaker feedback that notifies the user of incoming obstacles at about 75 decibels. As the user approaches an object, the vibrational feedback increases at a higher frequency, and the speaker also beeps faster. The cane is less than 1.5 pounds to reduce strain on the user's forearm and includes a rechargeable battery capable of 7 to 8 hours of usage. The cane is made from aluminum to ensure a robust structure, lightweight, and cost-effective. The cane also has a telescoping shaft for ease of portability and transportation.
And now we'd love to show you a sneak peek of what our smart cane can do. In the video, the buzzer and both motors will create feedback if an object is in front of it. If an object is only to the right, that motor will go off. And if it's to the left motor will only go off. And that's not all. The software is soon going to be completed with increasing audio and haptic feedback as the user approaches an object. Also, we were able to successfully 3D print a housing chassis that will house all the electronic components. The motors will be attached to the inside of the handle, and the sensor will be placed into this mount that allows it to point to objects located at waist level and above.
More people than ever are at risk of suffering during the use of a normal white cane. Our project reduced this danger and provided a better quality of life by lowering the number of upper body injuries sustained. In closing, current users of a white cane are unable to detect objects above waist level, resulting in serious injuries. Our smart cane resolved this issue using a distance sensor and haptic and audio feedback. Our distance sensor can detect objects at a distance of 3 meters, while the motors and buzzer notify the users how close they are to the said objects through an inversely proportional relationship.